Thank you very much, everybody, for joining this week's eCHO. With me today is Nico. I'll add him in.
Hey, good afternoon, everyone.
Yeah, good morning, good afternoon, whatever time zone you are in. For people who are joining for the first time, my name is Dan. I'm at iSurveillance. I'm part of the community team.
And I'm Nico, and I'm also at iSurveillance, and I'm in the technical marketing team. So I create content, demo lab tutorials on how to use Cilium, and happy to be here again.
Fantastic. So this is a pretty proud big release of Cilium 1.13 that was released last week or so, I believe.
A couple of weeks ago.
Yeah. A lot of work went into it. The engineers, unfortunately, are right back at it, working on the next release of Cilium, adding all those new and exciting features. But we're going to take some time today to go through, kind of some of those new features that we think are interesting, where you think you would find usage for them, and a couple of demos of some of those new features and things like that as well. But before we kind of start delving into the new release, the new technologies, the new features and things like that, a couple of things that we think you'll probably find interesting. Upcoming events. So next week in LA is Scale. I believe iSurveillance has a presence there. Cloud Native Day in Stockholm is coming up. And in under 50 days now, it's KubeCon Amsterdam. So I hope everybody's getting very excited for that. So KubeCon's quite exciting, but more exciting than KubeCon is CiliumCon, which is a half-day event taking place just before KubeCon actually starts in Amsterdam. There is going to be a half-day filled with sessions all around. I believe there's going to be some things around eBPF, but kind of a lot of stuff around use cases from Cilium. We have guest presenters up from all areas, from users to developers to meeting the maintainers and things like that as well. So we're super excited for this year's CiliumCon at KubeCon EU. Cool. Recent news, things that have kind of happened in the last week or so that I'm excited about. So Kernel 6.2 was released, which obviously is quite exciting. But for me, from an eBPF perspective, 6.1 is now an LTS, a long-term kernel going to be supported for a long period of time. The reason why this is important, and it's now available in distros like Ubuntu, etc., is that it adds a lot of eBPF helpers and eBPF functions. So people who are wanting to do a lot of cool networking stuff with things like connection tracking and whatnot, all of this is now available with a number of kind of helpers all out of the box. So making people's lives easier who are wanting to do clever eBPF stuff. I've noticed there's been a lot of talk about ambient mesh. I'll hand over to Nico here just to kind of explain what ambient mesh actually is. It's being talked about quite a lot at the moment.
Yeah, that's the Istio way of deploying sidecarless service mesh, right? Mm-hmm. Using what they call the Z tunnels to connect services together and encrypt them. Pretty cool. Did some tests a few weeks ago, and it looks very interesting.
Sure. Yeah, good for reducing all of the additional load from sidecars running absolutely everywhere, and kind of shrinking the layers and making things a bit simpler in terms of how things are deployed. Awesome. Congratulations to our friends at NS1 being acquired by IBM this week, or announced that they're going to be acquired by IBM. Additionally, spinning out of NS1 is Netbox Labs, which is now its own thing. So for those that are looking and have on-prem environments and want to kind of manage inventory and IPAM and things like that, Netbox is your tool for that sort of thing. Mm-hmm. Cool. So Quok, I don't know if anybody's noticed this yet. This was on the Kubernetes website a couple of days ago. Kubernetes without the kubelet. So for those that are deploying kind of Kubernetes themselves, you'll deploy the kubelet on every node that is to be managed, and Kubernetes, the API server, will ultimately communicate with the kubelet to tell it to do things. Quark is a new project that's recently been announced, which is Kubernetes without the kubelet. So how does that work? Well, it's largely for testing large-scale deployments. So if you really wanted to test scale at the moment with Kubernetes, then you need to get a very large checkbook out and pay for as many instances as you can possibly afford, and then have the API server eventually blow up because it can only scale so far. So Quark really is allowing for really big scale testing with kind of the Kubernetes cluster platform.
Yeah, and it's pretty cool how you can essentially create nodes, create pods, do some deep deployments, and as if you had a real, big cluster out there. And it's great to see things like, in the network world, we have Container Lab to create like virtual network along the same lines. And this is more around virtual clusters. But yeah, the more methods like this to help people learn and try new things, the better.
Yeah, absolutely.
It's really cool.
Yep. Cool. Yeah. And then the final thing that I thought was kind of crazy to kind of get your head around was the thing called Okra, which is a project managed by a company called Mac Studios, who they're like not best to describe it. So basically kind of a provider of like AWS is a provider of virtual infrastructure and sometimes bare metal infrastructure. Mac Studio is a provider of, you can basically get access to like a Mac Mini, for instance. They've announced a system with AWS where effectively there's a Kubernetes cluster that you can send some YAML to, and instead of it provisioning a pod, it will provision you a Mac OS instance for you to actually then interact with and develop on. So I believe this is largely being kind of used with Apple at the moment. So they basically, their developers can get a bit of YAML, ask for a bunch of Mac OS instances, and they get that back, and all managed by Kubernetes though. So pretty kind of quite crazy but interesting stuff.
And it's like the more Kubernetes just being used as a big distributed API server now, it's just like it's nothing related to containers. It's because you could do the same with like Terraform or any API call where you could just go and deploy a virtual Mac on AWS, but it's like, no, let's go and use Kubernetes and give YAML to people, because apparently people like YAML for some reason.
People like YAML. What can I say? But yeah, I mean, it is very cool. It reminds me a little bit. I haven't really followed on so much, but there was, as part of the VMware Tanzu work, there was the same sort of thing where instead of you going to vCenter and provisioning a VM from a template, you could essentially do a kubectl apply my VM YAML of type virtual machine or whatever, and that controller would ultimately be able to speak vSphere API and provision your VM, and you get your VM back at the end of it. Kubernetes managing pods, but now managing VMs, managing Mac OS. Who knows what it'll manage next?
Yeah.
Fantastic. Awesome. So that's kind of the recent news, some of the crazy things we're seeing in the news at the moment. Let's move on to the big one. So a lot of work has gone into this, a lot of work with customers. There's been a lot of release candidates getting this into people's hands. And now Cilium 1.13 is out there. You can upgrade to it, you can install it, you can make use of it, you can play with these new features. Nico here has been putting so much work into all of these labs that you can play with all of these new features. So Cilium 1.13. Well, let's kick this off.
2,101 commits since has gone into it. So a lot of work, obviously, many from ISO, but of course many from our external contributors as well.
Absolutely, yeah. We've seen a lot of work come from some of the big cloud providers, coming from some of the telcos who are kind of wanting to do, kind of need the capabilities that just, generally Kubernetes has never really been designed for. We're now starting to see a lot of that bridging the gap by being added into CNIs to allow cloud native networks to kind of interact with, interact with traditional networks. Being able to peer with BGP, being able to provide kind of network configuration, being able to support different protocols and things like that. So, yeah. We'll quickly go through some of the new features in 1.13. I'm just going to bring up. Do you want me to bring up your deck if that's okay, and we'll kind of step through some of that?
Yeah, I can do that.
All right.
Just give me 1 second.
One additional thing as well. So at the last KubeCon, Cilium was proposed to move to the graduated status at the moment. So there is a lot of work that's kind of happening behind the scenes. A lot of pull requests flying backwards and forwards, and a lot of dotting the I's and crossing the T's to hopefully get Cilium into the graduated space inside the CNCF.
Oops. Can you?
I can, yes.
Yeah. Awesome. That's a short version of the deck, actually. We've got a really big, with like 25 features, but I had to pick my favorite 10, which feels unfair in a way because it's like picking, one of your favorite kid. But it's there was so many good features in there. Whether you're more into networking or security, container runtime security, or encryption, observability, if you like Grafana, if you're interested in software supply chain security, service mesh, it's just there's a long list there.
Yep.
Cool. I guess should we go through a few of them? And
yeah, sure, absolutely.
Yeah. I would say that's probably the biggest eye-catching feature, and that's a gateway API support, fully conformant, and that I've been testing this for with release candidates of 1.13 over the past few months. Works great, and maybe we can have a look at the demo in a bit.
Sure. I think just for people that may not know, gateway API. What actually, what is it? Where is it? Where did it come from? Kind of thing.
So traditionally, what you've needed to route traffic into your cluster is an ingress resource or an ingress controller, where you essentially define your HTTP routes on how you want the traffic based on, on that header or that path to send towards that backend service. Right? So that's how you kind of direct traffic that is entering your cluster. And ingress was in kind of beta for many, many years, and there was some number of limitations with ingress, and it was never really. It's commonly deployed, but it's never been perfect. And the SIG networking group for Kubernetes has been working on its replacement, kind of long-term replacement, and that's what the gateway API is. And again, it's a way to route traffic into your network. I've been playing around with gateway API for over a year now, and it's just pretty simple. It's almost like if you had like a front-end load balancer and you just want to tell traffic where to go based on using some kind of filter to match traffic, and say, okay, I will send it to that service, or I will send it to other type of service, it's quite easy to get your head around.
Yeah, I guess then. So really, it was kind of there to almost kind of democratize the behavior of ingress controllers to a certain degree, I suppose. Prior to standardizing it, there are a lot of things were called ingress controls, but they would effectively sit almost in front of the Kubernetes cluster, take traffic, and it was each implementation would decide how they would kind of move their traffic around and where they would send it. Whereas the Gateway API project, SIG network, API, I believe it's called, or whichever group it's in, have now standardized it as part of kind of the Kubernetes standards body to define a number of different types of objects. There's two that we can see here. So the gateway API, which is kind of the parent object, and then the HTTP root object defines, kind of the behavior based upon the path of the HTTP request.
Yeah, and it's we're actually working on a bigger blog post that's going to come out in a couple of weeks, hopefully, that covers all the gateway API use cases we've got, with some more kind of videos and demos. But I guess what I like about how they looked at the project, and they really were focusing on who's using the ingress. It wasn't really about making it better from a technical point of view. It was like from a role perspective. I think the problem with ingress, it was this kind of one single resource. And if you have multiple teams that are trying to update and change that resource and adding new routes, it get messy. So one of the things they've done with Gateway API is really decouple the Gateway API kind of main configuration from the actual routes definition, right? So different kind of APIs there. So
I guess it means that all of the different implementations of ingress controller now all have to kind of adhere to the same standard to a certain degree. So I'm presuming you could effectively have multiple different types of ingress controller that behave in the correct way, and depending on your ingress into the cluster, tag it to a different whatever implementation if that's what you want to do, and things like that.
Yeah, and I think that was the other appeal of I guess gateway APIs. I guess if you look at ingress, because it was kind of limited what the APIs that came with ingress, what the ingress developers did was adding annotation to specify how to route traffic or load balance traffic. And so it became very inconsistent if you go from one ingress controller to another. And with Gateway API, you because we've got like 5-6 years of experience kind of using ingress, it's a more consistent approach. So I guess the benefit here is you can pretty much use the same configuration, and just if you say, okay, I don't want to use the Cilium Gateway API anymore, you can use another one, but you can reuse the same config. Whereas with annotations, you can't do that because they're tied to your. So yeah, it's brilliant to get. I'm already started to use the 1.14. What's going to come into 1.14, and we're actually adding more capabilities and features to the Gateway API implementation. And we'll watch out. Look out for some more content and labs about this.
Excellent. Yeah, it'd be good to see how it matures. It's Gateway API itself, I think, is at 0.6 version at the moment.
Yeah.
So it's got a little way to go, but I mean it's already kind of production ready. I believe people are now kind of using it as their standard and moving forward with it.
Yeah.
Awesome.
Cool. Should we do a demo in a bit, or?
Well, I mean, we've talked about it. If you want to jump into the demo now, and we'll show people what that looks like.
Sounds good. Right. And I'm going to cheat here because I am lazy, so I'm just going to use our own labs. Hopefully you can see clearly.
I'll remove myself to give you more screen estate.
So again, if you want to go and play with it, you just go to our iSurveillance.com/labs, and you'll find a set of I think we got about 15 labs now. So there's a Gateway API one, and when you launch a lab, we pre-install Cilium for you, and the main requirement here is you need a kube-proxy replacement, either partial or strict. And you need the actual CRD for the Gateway API. So in version 1.13, we're using Gateway API 0.5.1. In version 4.14, I think we'll be using version 0.6, which is the one that that I was just referring to. And so I've got my CRDs already deployed. And if I look at my Cilium, so yeah, it's all okay, deployed. And if we look at the configuration, I've got Gateway API enabled. And actually, I'm going to skip this, but yeah, if you want in the lab, we provide a bit more explanation about what the Gateway API lab actually is and how it works with, using this kind of the split of the gateway and the HTTP routes, for example. So for this lab, again, I'm giving a very, very quick demo of what we're using for our sample application that we're going to route into. Is a book info, which has been, I think, deployed by the eCHO team. And we might as well reuse it. So let's go. It should take just a few seconds to go and create. So the book info is microservices-based applications with multiple microservices running different types of programming languages. And we are almost ready to go. Just waiting for product page, and we're good. All right, so we got our application up and running, and we have a set of services that are deployed, and they're all kind of cluster IP services, so which are meant to be internal services. So what we want to do is provide access into the services by using Gateway API. So we're going to go and deploy our gateway. Go to this. Go, and we'll have a quick look at the configuration. So gateway, so it's pretty simple. It's just like 10 lines of YAML. It's as you can see, it's called a gateway. We've called it my gateway, and you can see the class, which is a Cilium, because it's a Cilium gateway API. And what we're doing is we are listening on port HTTP, and that's it for the main kind of gateway configuration. And then what you can do is you can attach a number of routes to it, and then traffic will hit the gateway, and then depending on some of your criteria, it will go to a backend, what we call it a backend reference, which is just the name of the service we've deployed before. So if you look above, I've got a details service and I got a product page service. Right? And if I access my gateway API, and if I use a /details path in my HTTP request, I will send that traffic to the details service over port 9080. Right? That's all there is. That's how we create rules in the HTTP route manifest. You can see I've also, what you just have to make sure is you link up your route to a specific gateway. Right? So I've linked my route called to this one here to my gateway, which is the Cilium one. And again, one of the benefits here is you could have like multiple gateways for multiple different use cases. You could have more internal facing gateway, external facing gateway. And again, you can have different rules depending on your on your requirements. So now what we just want to check is, can I actually access it? So see if the live demo is going to work. So if we go back to the actual services, since we've deployed the gateway, what it's automatically created is a service of type load balancer, which again enables us to access an internal service. And we've allocated an external IP, right? And that's how we're going to go and connect to it. So let's go and find the name of the pod. Let's just go and straight here. What I'm doing here is I'm doing a curl from my station to the gateway, and because I match the details path, it takes me to the details service, right? So essentially what we're making is just a call to that book info application, and book info application is just a database with different books, right? So what I've got here is I've requested the book, the details of the book ID 1, which is a Shakespeare book. Right? So I've been able to access my applications going through the Gateway API based on the path of my request. So, that's pretty cool. And do another example because I know we could go on for a while about this. What we can also do, if you look back at my HTTP route specifications, instead of matching just on the path, you can also match on the headers, right? So depending on the specific header or whether the value of the header or the query parameters, you can again send that traffic to a specific service. So here, if you match this header, these query parameters, and this method, we'll send the traffic to product page over port 9080. So here we go. So again, the product page is just a HTML file, just returns the simple bookstore application, which would be something that you would read instead of just curl like this. But it's just to show that we can access traffic based on specific HTTP parameters like headers and queries. Make sense?
Very cool.
Awesome. So excellent. Yeah, that's a very big one, and there are more use cases. And if I go back to slide here, you can use it. I've just shown an example with HTTP, but you can also use it with HTTPS and do some kind of TLS termination. That's also in the lab, and we've got another lab coming soon with the traffic splitting. So that's if you want to balance some of the traffic to full and some of the traffic to bar, you can do that. You can put weights. So for example, like a 50-50 split or a 90-10 split, if you want to do some kind of canary testing.
Okay.
And again, it's just literally just like one parameter is weight, and it would automatically do that for you. You don't have to go and install something else.
Very cool.
And the header modification is just a way to, for example, add a header to a packet, remove a header, update the header. Again, just using the Gateway API.
Excellent. Yeah, so there's a lot of different kind of functionality bits in there. Really, it's not just kind of getting traffic to a service. It's changing the behavior, actually being in the data path. If you're modifying kind of some of the data, adding tags to it and things like that.
Yeah, and I think what's will be coming will be non-HTTP traffic, so just normal TCP, UDP, gRPC. That's what's coming, and I think in the next release, hopefully.
Fantastic.
Awesome. Cool. Right. This one is that's pretty cool. I don't know how many vendors have already implemented this, which is all about software supply chain. There has been plenty of attacks like the SolarWinds one, where some piece of software was installed and there happened to be a vulnerability in one of the components and packages of the application that triggered some serious consequences. And I think that's, given that Cilium and Tetragon are pretty important part of your data path, right? you want to make sure that it's that the provenance is authentic.
Yep.
So we use cosine from the Six-Star project to essentially provide a to verify how Cilium and Tetragon were built. It's leveraging GitHub Actions as well, so you can go back and see exactly what was when the image was created, and you get a list of all the internal components, and you can verify that the image and also the list of the of components is authentic, and so there's some couple of different levels of ways to validate that the image isn't a bill of material is accurate.
Yeah, I think there's definitely, kind of there's been so much talk over the last 12, 18 months or so around S-bombs and things like that. I think at this point, we're largely kind of getting to the point where you can validate your entire stack from top to bottom effectively. You have all of those, the generated reports which detail the components that actually make up your, so for instance, the SBDX file that is generated when we build Cilium.1.13, that references all of the dependencies that Cilium has. So you effectively have that visibility into not only that the Cilium that you're running is signed, but also what is actually Cilium made of, and which releases are in there. So if you're made aware of something needing changing, you have all of that information available to you now.
Yeah. So again, look in the 113 blog post, we give you a couple of examples on how you can go and validate it. It's again that easy. Just install cosine, takes a couple of minutes, and you're good to go.
Fantastic.
Right, this one is quite cool. I'm not sure how frequently asked it is as a feature, but essentially it's around providing layer 7 load balancing for Kubernetes services, and that's mainly applicable for gRPC traffic. And the reason gRPC is just a bit different compared to other type of traffic is the way you can't load balance natively gRPC on Kubernetes, because gRPC essentially multiplexes sessions on together. So you just don't know, if you just look at the layer 4 packet, how much traffic and how much gRPC kind of queries are group in one gRPC flow. So you need to be able to do it at the layer 7 instead of the layer 4. And there is a blog post again that I've linked in the blog, in the 113 blogs, that explains why we need layer 7 instead of layer 4. Anyway, so if you wanted to go and do layer 7 load balancing for gRPC on Kubernetes, what you would have needed would be to use a service mesh, or there were some hacks using like headless services, but it wasn't kind of easy. And so we were hearing from customers, and one in particular in the financial industry, and they told us they would really like it if Cilium can just use the embedded envoy proxy, and if you just add an annotation to the service, that it will automatically go and apply some layer 7 load balancing, which is what we've built. So again, I know, looking at the time, maybe if we have some time at the end, I can show a demo of this, because we've got a lab that lets you try this out. But yeah, just simple, nice feature.
Yeah, absolutely. I was researching this a little bit more because I mean gRPC it's everywhere without you really kind of realizing it. It's how the Kubernetes API speaks to CNIs, for instance. gRPC is the communication method between Kubernetes and Cilium, for instance, in order for it to instruct it to do things with the network and things like that. But it's also kind of massively popular in things like remote vehicles and things like that, where vehicles are kind of dialing back into big server, kind of big clusters to update them on health or location or things like that. So, there's going to be huge use cases for being able to load balance traffic that's coming from almost IoT devices and large microservices environments.
Yeah, it's kind of a modern alternative to REST API, but like GraphQL as well, kind of more adapted to streaming of data, from what I can understand.
Yep.
Awesome. Tell you what, I might just skip this one because of time and because I just love big TCP so much. I think it's so cool. It just first I love the name, right? You can't just hear big TCP. I was curious what is big TCP, and
it's big TCP is what it is.
It's very big TCP, and I guess what's interesting about BTCP, and they're actually I wrote a separate post about it because again I was just very excited. And I guess so BTCP was created by some Linux kernel experts at work at Google, and it was merged into 5.19 kernel, 5.19, and that which came out in June. And by August, we had support of this feature in Cilium in one of the early release candidates for 1.13. So again, kudos to the Cilium developers for including this feature so quickly. And it's pretty much as it sounds, right? Just about being able to have bigger packets, and the fewer packets you've got, the fewer you have to process. And because originally, when TCP was built, it wasn't designed for the 100 gig of beyond networks that we have in some of the data centers. So there's been different kind of methods to increase the packet size. We use a GRO and GSO within the Linux kernel to kind of aggregate packets together, but that went all the way up to 64K, and you couldn't go beyond 64K because of the header length was to the power of 16 or something like this. So you couldn't go, literally, you couldn't. So if you wanted to have a bigger packet, you needed to have a bigger header, which would be bigger, so you could specify a bigger length. And so the people who came up with BTCP, they looked at a header in the IPv6 packet, where you can, which is a bigger header, where you can say that packet is going to be up to, you can actually have up to 4 gig.
Yeah, I was just thinking if they suddenly changed the header layout on at least TCP IPv4, how do existing devices kind of understand that this 16-bit value is now 32-bit or 64-bit or whatever? It's just going to break everything, but that's not the case here, is it? It's IPv6 at this point.
Yeah, and it's as you just said, at this point, but because actually they are looking at IPv4 support for big TCP. It's something that is on the Linux kernel mailing list.
Okay.
Some people are already talking about it. It's finding a way to
hide
address
some
this use
bits.
case. Yeah.
Crazy.
Why not? And I think what I found really cool is when I first read about big TCP, I thought that's never going to work because I've had the pleasure to have to look at MTU and jumbo frames on the network, right? And it's a nightmare when you have like MTU mismatch, you know. So what I hadn't understood was really the big TCP is about the traffic that goes through the Linux networking stack, right? It's not within the physical network; it's inside the stack. So it's invisible to your physical network. It's just as traffic kind of enters the stack and goes through all the way up to this for the CPU to be handling the packets, which is going to group all these packets into, for example, 512K. And yeah, if I look at here, if you look at some of the performance, and again, it's something I could just do myself. As I said in the blog post, it took me about 50 minutes to get to be up and running. I used a dual stack kind cluster, installed it, and it was just like one feature. You just enable the big TCP flag, and then what you get is a 592K packet size, and the default one, as you can see here, is 64K. Right. So literally, the only thing I had to do was find a machine that has this 519 kernel, enable Cilium with this feature, and already I was able to get that kind of bigger packet size. And then I run some tests with and without, right? So without big TCP, you could see that was the latency, right, of the packets, right, within my my cluster. And with big TCP, the latency went down, by whatever it is, like 20%, and again, the number of packets per second, number of transactions per second went down. And again, if you compare like some of the tests that were shown at KubeCon, went up from like 52 gig to 60 gig, which 8 gig. That's pretty decent.
Yeah, absolutely. Yeah, it's good. It's interesting. I mean, we're getting quite close on time here, but I did see about a year or so ago there was an article. I don't know whether it was kind of one of those for stirring up discussion, but is it time to kind of dump TCP and move on to a new protocol? Which the TCP header is quite big. There's a lot of information in there, largely because older networks that weren't as reliable or were a little bit flaky, and people were sending data over telephone networks and things like that. Packet loss was quite common, and the TCP header was largely there in order to kind of find things that were broken and ensure that packets were resent and things like that. Networks are a lot different than they were when TCP was created. We have massive pipes to send traffic down and things like that. So do we need these big over-the-top headers? We could probably look at alternatives to that, but this largely seems to address a lot of the issues that was kind of raised in that inflammatory post from a year or so ago.
But if if you're looking at building a new IPv6 cluster, I would really look at this. Go and try it. Again, it's pretty awesome.
Excellent.
Right. So I guess we can talk about this briefly because you did cover this with Dylan maybe December or something.
Yes. Yep.
Which is great for connecting your cluster to extend. It's more connecting on-prem cluster with the rest of your network, right? So about go.
Yeah, there's two really exciting pieces that are part of this. Really, one is IPAM. So in the cloud, you just do a kubectl expose something, and you magically get an external IP address. You don't care where that IP address came from. When you own the network, someone needs to decide what is a good IP address that you can use. And normally, if you want to do something, you normally raise a ticket, wait a while, and hopefully a network person will look at that ticket and say, right, they can have an IP address from this range. A note of it is made in a spreadsheet, and then you can use that IP address for your work purposes. IPAM is IP address allocation management, and that is now within Cilium. So you can effectively say, here's a range, and when you need to do something, when you need to give a service an IP address, Cilium will take care of giving you one of those IP addresses from the range that it manages. So it takes care of basically looking at IP addresses and allocating them where needed. The other awesome piece to the puzzle really here is exposing that IP address to the rest of the physical network, and that is done through BGP. So Cilium now can be given configuration of your top of rack switches, and when you create a service, it will go to those switches and it will say, for this IP address, send the traffic to me. And when I have that traffic, I will make sure that it is then sent to a pod or pods that are part of the services running.
Yeah. And it's,
awesome, awesome stuff.
Yeah, it's good because, again, you look at what Cilium can do. Like before, I guess in the past, you needed some also tools to do ingress or to do gateway API or to do BGP or to do service mesh, and now you kind of deploy Cilium and you get all this goodness. Same for the load, IPAM. Again, you needed Metal LB to give you an IP address, but you just use Cilium now for this.
Yep. Or handcrafting your service YAML and getting that IP address from your spreadsheet is the alternative way of doing it. Awesome.
This is also very cool. Again, that's more like for, I don't know how common people are deploying IPv6 based cluster. I'm seeing, I think in our Cilium Slack, I'm seeing more and more questions from people who are deploying IPv6 based clusters on one of the public cloud. So we've been working towards some NAT4.6 and NAT6.4 support, which again comes with Cilium. And it's, I guess, a couple of different use cases. Is one, if you've got an IPv6 only cluster that needs to access an IPv4 only system. One example we've got working was GitHub, because GitHub is still IPv4 only. Fortunately, which I know they're working towards, but so what we did in the demo is we got access from an IPv6 client to GitHub using the Cilium NAT6 to 4, right, which is translating from IPv6 into an IPv4. And then the other way you can use it with Cilium is if you've got Kubernetes, again, IPv6 cluster that you want to expose to an external client, you can use NAT4.6. So both are pretty nice. Ideally, you don't want to have dual stack or NAT4.6. You want to be IPv6 only, but things can.
Well, people have been saying this for years, and we're still a long way away from unifying on one standard at the moment.
That's it.
Excellent.
SCTP. You also had a session.
I did. Yeah. I mean, I'll quickly kind of just go over it again. So SCTP, a protocol that not a lot of people kind of talk about, I suppose, but it really is a kind of an interesting almost stopgap to a degree in between both UDP and TCP. So it supports some of the robustness of TCP, but having the leanness of UDP. And it's being used more and more, especially in kind of the telco VoIP space and things like that, where they want to be able to have reliable traffic, but also low latency and things like that as well. So we had this is external features that were added into Cilium. So this was some fantastic developers in the open source space that kind of adapted Cilium and sent us their code patches, and we've implemented and added those into Cilium moving forward. So SCTP, the protocol alternative to UDP and TCP, we support that for pod-to-pod communication, pod-to-service. We also support that through network policies and with Hubble as well. So not only do we have the policies, we have the observability and the support for SCTP traffic moving forward.
Yeah, that's pretty cool. Again, we've got a lab for that. I just had to plug it.
No, you do. You have to plug your labs. They are fantastic.
Yeah. Right. MTLS data path. That's a cool feature, but actually not something that is really user facing right now. But it's part of our wider plan. If you look back to the blog post that Thomas Graf did back in May 22, where he talked about the future of Cilium service mesh and how what we're looking at doing from a security point of view. And what comes with 113 is essentially the ability to data path implementation to support this kind of service-to-service authentication. And we'll be able to plug in different identity managers like SPIFFE and Cert Manager and like Vault. Again, even it's not kind of ready right now, but we've put the groundwork. And I imagine in 114 there will be more to come about this.
Fantastic. Cool.
All right. Talk briefly about this one. This is an enhancement to network policies where you can create a network policies based on server name. Which it's, again, we're using Envoy for this. We use Envoy for, lots of different things, but it's just a nice little feature for people that may want to implement network policies that, down to that granularity.
Yeah.
I know we're looking at the time, we're a bit short, but that was one of the last feature. We've got lots of really cool integrations coming out with Grafana. Just on Wednesday, I was running a workshop which was around our zero trust security lab that lets you visualize some of the network policy, whether you see hits on a network policy, right? And that we can export all the data to Grafana.
Yep.
So you can see if, and in the lab, we go from like a Kubernetes cluster when there's no network policy to one that is locked down with zero trust, if you like, but where we've created all the policies, based on actual traffic, and then you can see on Grafana how that looks. And that's so we got lots of interesting integrations between Cilium, Hubble, and Grafana. We've got this one, which is for applications that support tracing. And I think there was a eCHO that session with Anna and Liz a few months ago, where they went through it. So you can look this up, but it's again pretty cool how you can really get really granular data of a specific application and links this up, pull kind of network data from Hubble into your application observability, right? So again, this was in Liz and Anna went through in the eCHO a few months ago. I recommend you watch it.
Yeah, I think there's two kind of quite cool sides to this to a certain degree. One is Hubble, hooking in through eBPF to have all of that kind of information of what's actually transpiring, what that looks like. So capturing all of this information. And the second really is all of the work we've been doing with Grafana, just to kind of visualize most of it kind of out of the box now. So, I mean, I kind of set this up and played with it a month or two ago. And it's only a kind of as anybody would expect with Kubernetes, adding a bit of YAML to your cluster, and then the next minute you have all of these graphs detailing, kind of all these layer 7 kind of hits that are happening, and kind of all of the behavior that's happening under the covers. So really kind of quite transparent through eBPF, but then fantastic kind of visualization of what's actually occurring within the cluster.
Awesome. And I think that was the last big feature I admire. There's many more if you've got about 25 minutes to go through this.
I suppose there's kind of almost two sides to this, really. There's so much video content out there detailing all of these new features that we'd love you to go and watch when you have the time to learn more. And then if you actually really want to play with these new features and get your hands dirty with what this looks like, there's all the labs. So there are just labs for all of these new features that you can play with, and kind of get your head around how they actually work, what they look like to actually implement, and actually see them in action.
Yeah.
Fantastic. Well, I think we're kind of coming to the end. I think really kind of wrapping up, it's kind of quite clear that what we're really starting to see now is a lot of these features to me really feel like we're integrating more with environments, pre-existing environments, meeting kind of requests that customers, we're answering the questions that customers are asking, that end users are asking. We're starting to see different types of workload that require different types of technologies to be implemented, which I think is really, kind of starting to see maturing in the product as you start to have to integrate back and things like that. So that is Cilium 1.13. Thanks to everybody who has contributed PRs, raised issues, done QA testing on the release candidates, played with it, talked about it. We're just super super to get Cilium 1.13 into your hands. Thank you ever so much, Nico. Is there anything you want to wrap up with?
No, thanks for having me. And I've done enough plugging for today.
That's fine. Nico is the labs master. So if you have any ideas for any additional labs, then he is definitely one of the people to go and raise your ideas with. As mentioned, there's a number of events coming up. We are at most of those events. We're a friendly bunch. Come find us, ask us questions. We'll do demos. We'll point you to the labs. We'll be happy to help. And with that, thank you very much, everybody, for joining this session. And we will see you all again next time.
All right. Take care.
Thank you. Bye.